Last class we talked about pointers, so we're going to talk about one more aspect of pointers, and that's function pointers. So they're pretty straightforward once you've mastered the concept of pointers. So all we have here is a function I've called some action, and I'm going to use the term action. This has nothing to do with C++, it's just for convenience. But I'm going to use action when I'm talking about something that returns void, and I'm going to use func or function for something that actually returns a value. So all this does is see out. This is nothing new so far. What's going to be new is instead of just calling some action, we're going to call it through a function pointer. And the way you declare a function pointer is the same way you declare a function, really, for the most part. Let's just call our function pointer action right now. And so normally you would just do this. So the only thing you do differently is you put the asterisk, the pointer symbol right there, like that. So now we've got, thinking of this pointer, we've got a pointer to a function, that's what these parentheses are, that takes no parameters and that returns void. That's what this statement says. So we can assign that to anything that matches. So if we have anything that takes no parameters and return void, and we happen to have that, so we can just say some action, and that will work. And equally, what C++ is actually taking the address of this for you. It recognizes the syntax, but you can also explicitly do it like that if you want. So that's all there is to it. That's a function pointer. Just like you declared a function, only we're inside code now, right? We're not up above where we would normally define a function, but inside where we have code, executable code, we write pretty much the same thing. We just add the parentheses and that asterisk, and then we can assign it to what it is we want it to invoke. Now it hasn't done anything yet. We actually have to invoke it, and so the word action is the new name of, if you will, of our variable. So we have to use that, and then we just invoke it like we did any other function. So let's build that, and let me get everything back here so you can see the results. There we go. And let's hit run. And there we are. We're in some action. That's because we called, that's what some action prints out, and we called that through this function pointer. So because you're going to see it a lot, this syntax, if you it can get kind of bulky if you're going to use function pointers a lot. So what everyone tends to do is create a type def. It's just a facility of C++. Use the keyword type def, and then you can just paste the same code in. And then what type def does is it assigns the name action to that. So it assigns it to a pointer to a function that returns a void. It's just that action is basically now a synonym for all that. So doing our same example, so now you can think of action as a keyword. It's not a variable anymore, so we need a variable. So now we can do that anytime we want, and we can't do this anymore. We have to actually use our variable name, myAction. Okay. So now we've done the equivalent. It's just we've kind of moved this up into here, and if we want to do more than one, all we ever have to use is this word action. So let's build that and just run it to prove that that works. Okay, so we're still in some action. Okay, so invoking a function works pretty much the same way. So let's just let's do our type def first. But now instead of void, we have to have our return type, and then again, and let's call this func. Okay, so now we've got the equivalent of a keyword called func that we can use, just like we used action. So we can say func. You can probably see where this is going, right? My func equals, what do we call it? Some func. Okay, like that. And now let's capture the return value. The int result equals my func, just like that. And then in addition to it prints out there, we can print it out here to make sure we get the right thing back. So result and result. Okay. Alright, so let's build that. Run that. And I had an error, so I had a typo somewhere. Oh, I forgot my output. Okay, and it looks a little better. And then that runs. Okay, so you can see it works just like an action. We're calling a func. And there's nothing magical about not having parameters either. So let's just let's write something that so some action, and this takes x. Okay, and I could use the same name because it's overloaded, but let's just use a different name just to make it a little clearer. Okay, so see out, and we're in some action 1 now, and let's just put out the value of x here as well. Okay, and that's all we need to do there. And so now we need to create another type def because it's a different type of function. This signature wouldn't work. So we need to say that this is action 1 and it takes an int. Okay, I got my parenthesis in the wrong place. It has to be here, and then this has to, so you see all I've done is the same as this. I just put an int there for the type because this is action is a pointer to a function that takes no parameters and returns void. Action 1 is a pointer to a function that takes an int and returns void. Okay, so that's the type def for that. So now action 1 matches this signature here. So I can come down here and I can say action 1, and my action 1 equals some action 1, and we can pass in, let's pass in result. I don't know, let's pass in result plus 5. Okay, just so that we get a different answer. And then down here, that's it, because we're not, this isn't a function. So now we're just gonna call this my action 1 like that. Okay. And we run that, and we get an error. Too few are, oh, sorry. You gotta pass, I did this wrong. Okay. Oh, my recording accidentally cut off, so I'm not sure where I was when I did that, but I did that wrong. So when you create an action to something that takes a parameter, you still just assign it to the name of the action or the function that takes the parameter. Then when you invoke it down here, you pass in the value, just like you would normally. And let's build that and run that. And there you can see some action 1 is now returning 15. So it probably seems like, well, what are we getting out of this? And in these examples, not much, but it really becomes, it is very useful, and it becomes even more useful when because you can pass them around. So so let's just call an action and a func. Normally you only pass one function pointer into a function. You're trying to inject into some function some specialized behavior. You've got a bunch of code that otherwise you'd have to repeat over and over, but if you could pass in the few lines that are unique, then it can do all the things it has to do. Then it can invoke the function, then it can do any cleanup or other code that it has to do after the function's called. So what we're going to do is we're going to pass in, just as an example here, we're going to pass in an action and a function just to show them both working. Okay, so like that. And then we're just going to invoke them. So let's just put a message so that we can see that we're inside here. And then we'll just call the action, and then we'll save the result. The result equals the func. Let's spell it right. Okay, and then let's just go ahead. Now let's just put out the result here. Cout result is result. Okay. So then we'll just call this as a normal function. We won't make a pointer to a function that takes pointers to functions. So let's just call action and func, and it just wants, so let's just pass in my action, and let's pass in my func, and you'll see this will compile, and we'll see right there, make this a little bit bigger, that we're in call action and func, and then we were in some action, and then we were in some func, and it showed a 10, and the result was 10. So hopefully that gives you a good idea of the power of function pointers and how to